So my name's Sam Newman. Hopefully I'm going to share with you today some lessons that I've sort of extrapolated from work I've been doing with ThoughtWorks over the last 10 years, and a lot of my colleagues have done, really in the art of taking the big and making it smaller. And here specifically we're talking about how do I take a big service and make it a smaller service, a set of smaller services. Talk a little about why we might do that, some of the benefits. Hopefully you're going to come out of this with some real practical understanding about why you'd want to do this. We'll also talk about a topic called microservices that many of you may have heard about. Some of you may be coming to my tutorial that I'm doing with James Lewis on Thursday, all about this subject. Just in case you're worried, only some of this content will be on the Thursday. There's a whole load of other stuff coming up. As I said, I work for ThoughtWorks. I'm actually also on the technology advisory board for ThoughtWorks, and we put out this thing called the Technology Radar. It's freely available, comes out every 6 months. We mostly write it to share our own experiences of different technology and different techniques. And we typically completely miss the point of what's going to be controversial. So, saying that Maven is a horrible system, I assume was common sense, but apparently a lot of people got angry about it. If you want to debate the relative merits of things on the tech radar, come find me afterwards. But as I said, I am here today to talk about big things and basically how do you go from the very big to, well, the smaller. There are lots of reasons, actually, why you might choose to break apart systems. A lot of them come down to the illities. Durability. Often you can achieve different types of durability for your system by breaking it up into smaller parts. Maybe only some parts of your system need highly durable services. It's more feasible to make that service more durable if you only isolate those feature sets you care about. You can actually split it apart and treat those concerns separately. Technology is a good one. If you were here earlier and you saw Neil Ford, I wasn't really paying attention, but I think he was saying something along the lines of, you should just sneak in new languages wherever you can. This is a very good way to do that. If you break apart your big monolithic service or system into smaller parts, you actually create space where you can experiment with new technology. You can actually take a component that might represent a smaller risk to your business and say, well, that's where we're going to try the new language or the new framework. Geography is a good one. I'm here, my customers are over there. Maybe I should distribute my system such that some of my services are closer to my clients. Team structure and organization is a really important one here. How many of you here have heard of Conways law? Okay, so probably only about 15% of the room. It's probably one of the most important laws you'll see in computing. It's worth reading up about, but basically says that the design of our systems will follow the communication pathways in our organization and vice versa. So often where you find things like, I've got 2 teams in 2 different geographical locations, that's often a really good reason to have them working on 2 separate services that are collaborating. I can't go into that in too much detail today. There's also speed of change. When you break up a big system into smaller components, you have the ability to deploy changes to independent components without affecting the whole overall system. My talk at GOTO last year was actually on the subject called Designing for Rapid Release. There's a lot more detail about characteristics of services that make them easy to release frequently. Before we talk about breaking a service apart, though, we should maybe step back a bit and think, what is a good service? And I'm going to keep it fairly high level. When we think about a service, I think there are 2 characteristics that are very important to consider. The first is sort of high cohesion. If I've got a set of functionality around a given area, I would like it to be sort of in the same place, because it gives me opportunity to create abstractions around that piece of code. If I fix a defect, I can fix it in one place and one place only, or at least closely together. It also makes it easier for me to understand and comprehend how my system works. I've got lots of like-minded stuff in one place. And there's also loose coupling. I don't want my systems to be composed of services that are so tightly bound together that I can't change one service without changing the entire system. Big monolithic systems are quite hard to change. It's even harder to change distributed systems that are very tightly coupled together. I'll give you an example of what I mean by loose coupling. So imagine I've got a service And inside my service, I have my internal representations of the work I'm doing. This is effectively my objects I've got in memory, and it's how I'm doing my work. And let's imagine that I am providing a service to other things around me. And so here they are, and they're wanting things from me. Now, if I allow these services to reach right inside me and grab my internal representations, then effectively I have an unfortunate side of coupling. It's now hard for me to change the internals of my system, the internals of my service here, because the things on the outside are sort of grabbing hold of it. It's like when you're having a conversation with somebody, we're trying to speak verbally, and then suddenly he starts reaching into your brain and grabbing all the synapses. It makes it very hard for me to do my job when something's reached deep inside and grabs hold of me. And this is actually how you can very quickly create these sort of intricate mats of distributed systems where things are very, very tightly coupled together. And a very common example of this is where people take internal representations, serialize that, and then share that over the wire. They become inadvertent coupling points. Russ talked earlier today in this track about things like Conway's law. I talked about more than that in my previous talk, Designing for Rapid Release, about techniques how you can avoid that. So we really want to have this concept of high cohesion and loose coupling when we make good services, because this sort of coupling process can become a bit of a mess, and you end up with a big old, well, basically a bit of a nightmare to try and pick apart. Now, this is a fairly modern conference. You're all fairly modern people, and I was trying to think of an example, a good example to help illustrate some of the lessons I'm going to talk about today. And so I was thinking, well, what are all the kids doing nowadays? Something cutting edge. So I think the future of the music industry is basically about the physical delivery of media. So here we are. So our example for today is going to all be about how CDs come from a website and get arrived at your door. Let's think about what's going to happen in that operation. We're dealing with physical things. I like physical things. You can point to them and say, that thing is there. It's not over there because I can see it, physics aside. And so imagine with a music shop, here I am. I have my warehouse, and my warehouse contains many, many things. It contains CDs. It contains breakout areas. It contains calendars of questionable content, boxes and people. And obviously, people have to get paid, and lots of numbers need to be written down for financial reports. So my organization is probably going to have a finance guy somewhere. You can tell he's in finance. He has the blue tie. He's thinking very thoughtfully about, I wonder if I shovel all my tax through Luxembourg, if I can avoid. And he's writing things down with a pen. So he's a finance guy. He's thinking deeply. Now, things happen in the warehouse that the finance guy doesn't really care about. He's not really that bothered about the fact that the warehouse has inside it a forklift truck. He equally doesn't know, for reasons known only to the people who work in the warehouse, that the forklift truck is called Beryl. He doesn't even know where it. He just knows about some aspects of the warehouse. He probably needs to know about the inventory for purposes of financial reporting, but he doesn't need to know about detail. He certainly doesn't need to know about the forklift truck, doesn't need to know about the types of boxes that are involved, that are used to store the items, but he very much cares about the kind of products that we are selling and shipping, because he has to write out reports. So it's an interesting here, right? We've got within an organization, within the context of our music shop, we have people and responsibilities. We have the finance guy who does finance things. I don't understand finance. There's finance things being done by him. All I know is that pay slips come out at the end and reports. And he talks to the warehouse, and he might ask for specific pieces of information. Doesn't need to know everything, though. So effectively, you know, all the finance stuff is in the finance guy, and the warehouse stuff's in the warehouse guy. They're sort of talking over that line. How many people here have read this book, Domain-Driven Design? It gets lower every year, which does worry me a little bit, actually. It's a really interesting book by Eric Evans. When I first read this book, probably about 10 years ago now, it was when it first came out, I found the first half of that book to be the really interesting and insightful. If any of you have a repository layer or a repository interface in your code, you know, a user repository or the app repository, more than likely that the person who put that in probably read this book and thought we need repositories in our system. It turned out, actually, the interesting stuff's at the back half of the book, but I didn't read that until much later. There's a concept that Eric talks about in the book, which is one of a bounded context. So, bounded context. This is how Eric describes the bounded context. The delimited applicability of a particular model, bounded contexts give team members a clear and shared understanding of what has to be consistent and what can develop independently. Now, I think Eric's great with ideas and concepts. I have found this quite hard to understand. I found a more pithy explanation of what a bounded context was in a blog post, which is a specific responsibility enforced by explicit boundaries. So let's think about the warehouse and the finance team. The finance team have their job that they do, and they have a responsibility, an operation to carry out. They have autonomy. The warehouse, likewise, they have an explicit interaction point. I need the inventory report so I can do my details, so I can do my reports. Or you can summarize this all as sort of respect my authority. These are bounded contexts saying, I'm doing this, you stay out of my way, I know what I'm doing, let me do what I want to do. And when it comes to services, we're thinking about these concepts of high cohesion and loose coupling. These explicit boundaries between the bounded contexts are a great place to actually achieve that loose coupling. We talk and communicate across a fairly narrow, well-understood set of interactions. High cohesion, all the finance stuff's done by the finance team. This ends up being a really useful model when we're thinking about designing our own systems. Let's think about some of the capabilities that we might have within, say, our music website. Things I might want to achieve with my system. I might want to add something to my shopping cart. I want to check something out. I'm thinking about viewing the latest releases, searching the catalog, listening to previews. There's also about activities, responsibilities that are part of my online music shop. But you can already, when you look at things like this, start to group them together and create sort of like-minded things that sort of sit well, that have high cohesion. These become effectively bounded contexts. So some of the bounded contexts that might exist within our music shop are things like, well, a shopping cart, a catalog, a music library. And you will probably find that within your own organizations, people already know what the bounded contexts are, and their terms that already get used. You have teams, you have organizations within your own company already. The question is, how much of that is actually represented in the flows of your own architecture and your own systems and your own design? So one of the key things that we found is that when we find and take a big service and split it up in smaller chunks, if we can do it around these bounded contexts, we end up with services that have those two characteristics we like to look for, that high cohesion and that low coupling. So how do we achieve that? When we start with a big box, where do we go? Well, easy things at the beginning is to start simple. You get around a whiteboard and you start sketching out very high level, what are the bounded contexts that we think exist? And start coarse-grained. So maybe this is high enough level for the music shop. We think we've got like these 4 or 5 things in our system, really high-level things. The interesting thing with bounded context is they actually kind of nest. If we think about the context of this conference, we have the whole conference. We have the set of operations around the canteen. There's a set of operations around the coffee shop. There's the crew who run all the feedback sessions and make sure we get in and get out, all those sorts of things. Start coarse and start slicing apart. One of the easy ways to do this is actually just to look for things your language provides you in terms of grouping code together. I spent most of my professional life working in Java. Java has the concept of the package. The package is actually, from a programming point of view, a very weak construct. Many other languages do much more interesting things with packages, but they're actually quite useful as just grouping things together. A tool like Structure 101 can do a very good job at actually showing you your packages and how they interrelate. We're looking, remember, for that loose coupling. So when we're looking at our bounded context, we're looking for opportunities to see, are things two coupled together? So Structure 101 gives you useful pictures like this. So here I'm already seeing some things that seem like that might be about my business. I've got something called a booking criteria, commission plan, my report system. And you can start seeing some interesting things like, it's kind of weird, I can understand, so for example, why the business criteria kind of needs the commission plan, but I don't understand why that link's going back. That's not how our organization works. Why is my code looking like that? And the thing is, moving code is fairly easy. There's simple refactorings you can make. So if you have a tool that lets you visualize the groupings within your existing system, your existing monolithic code base, you can just, over time, chip away, shift stuff around, look at the flows, and get to a happy place. It doesn't have to be all or nothing. Very, very low impact work. And so over time, you can go from a place where your big monolithic service actually gets broken down inside itself into sort of packages that look like this. The reason I don't spend much time talking about how you achieve that part of it is because actually that's the easy part. And I think most of you are going to understand your domain better. There's a good book called Implementing Domain-Driven Design that goes into more detail about how you actually get into the detail of actually separating out these concepts. But often just by speaking to your business stakeholders, you'll get a lot of that information. The hard bit, as always, is databases. Because basically, data's cool, but databases suck. And they are often the biggest impediment to how you break apart systems and services. Some of the stuff I'm going to talk about are patterns actually in the Refactoring Databases book, which you may well want to read, especially if you're dealing with a nasty legacy database, because there's lots of coping patterns in there for how you separate and pull apart these systems. So here's an example. The core problem here is this is the most traditional way of people breaking apart systems, is to basically say, right, I've got my monolithic music shop, I'm going to put out my service, and we're all going to integrate back to the database. And that's kind of a bad thing to do, because if I change something in a music shop, I might want to change the schema underlying my service. Can I do that? I don't know, because my recommendation service is talking to the same database. We have a source of coupling. We need to break that apart. So you really do need to separate those things out and use separate schemas wherever possible. So you probably end up with something like this. I've got my packages. First thing you want to try and do is probably go from a single repository layer within your big monolithic service to actually separating out those repositories for being on a per bounded context basis. You do end up having different connection pools and things like that, but it's worthwhile doing, because then all of the work related to the catalog is there and visible, and your repository layer is actually a great way of visualizing the interactions with the data schema as well. You can see which parts of the schema the catalog uses and which part of the schema the warehouse uses. It's not the end of the story, of course, because obviously you have referential integrity between database tables that's not visible within the application tier. There, if you're using relational database, tools like Schema Spy are very good at helping you here, so you can actually see the relationships. Because we need, if I want to spin off the catalog as a separate service, I've got to chip all the way down and move that schema out. Let's look at some examples of that. So here we have a catalog and a line items table, and I've got finance and I've got a ledger. Not sure what a ledger is, but they're very important things. Ledger, and I've got to generate a report as part of the finance system. Now, in my existing system, when that report gets run, I'm putting together information from the ledger with additional metadata from the line items table to enrich that report. So I know how many of, it's not just I know that I've sold 50 items of SKU 123, I know that SKU 123 is the greatest hits of Justin Bieber. It's a very short album. So here I am, and I'm pulling this across. Now here, though, I've got the bounded context of finance reaching in to data that's kind of much more closely associated with the catalog. Now, if I want to separate those as services, that line is going to become a problem. So I need to kill that line. I may also have referential integrity from the ledger into the line items table. What I need to do is break both of those lines. And what I want instead is when the finance report runs, it should go to the catalog bounded context and interface and say, please give me the information I require. And that's a change you can make within the single service before then separating those out as two separate services that then get to maintain their own schemas independently. And then that relationship that within a relational database may be a foreign key relationship or something like that ends up being maybe something as simple as a link to another resource. Let's look at another example. Country codes tables. Country code tables are like the string utils of the database world. Every project I've been on seems to think that countries get created much more frequently than we release our software. And so that we put these country code tables in there so that, well, actually with some software that's probably true. But anyway, you know, you can put it in here so we can magically go in and add in a new line when a new island appears or whatever else. How am I going to split this up? Well, there's some odd things I could do. So the first step I could take is to give each bounded context its own country codes thing, which seems a bit odd, seems a bit excessive. I could equally just say, well, there's just static code. It's just static stuff, you know? I'm just going to put those country shortcodes in an enum and stick that in code and have some actually duplication between my bounded context. Russ talked quite well at the beginning of the day about how actually duplication between services is not necessarily a problem if it avoids coupling. In one environment, we actually took that those country codes and made it a separate service because there was a large amount of sort of metadata associated with general reference data, names of companies, things like that. And there was enough that it became a service in its own right to break that connection. Here's another example, a finance and my warehouse system, both talking to a customer record table. At this point, I'm going to introduce a fancy word, because I think both Neil and Russ introduced fancy words. So the word I'm going to identify here is reify. And I have a definition, not from Webster, but from Google, which actually from dictionary.com. So here we are, reify. Reify means to make something abstract, make it more concrete, make it more real. So if you look at this situation, I've got the finance system and the warehouse system both talking to a customer record table. The finance system is updating things like this customer paid, refunded customer, item returned, so I've refunded the amount. The warehouse system is saying things like, I received the return, I've sent the order out, and they're updating this same concept. The issue here is that we have an implicit domain concept that hasn't been realized. We've discovered it while going through our data schema. What's the implicit domain concept here? Customer. So there was something that we didn't know was there, and we found it. It's fun. It's like archaeology, this stuff. So there we are. Now we create a new bounded context. And it might be a very, very small one. It might actually be nothing more than a nice interface on top of some very simple Hibernate mappings. But now the finance system, the warehouse system, can talk to the customer context, which in turn talks to that table. And if I roll it all the way through, I could end up with 3 separate services that are then collaborating. One last example. Here we have the catalog and the warehouse, and we have a nicely generic table called item, because items are for storing items. And in the item table, we have information like this, that we have the BGs, 499, and we have 45. So BGs, 499 is information about the record, and 45 is how many items we have in stock. And so both bounded contexts care about that information. When you're browsing the catalog, you want to know how much it costs and everything else, and the warehouse needs to be able to update the inventory and all those sorts of things. But we effectively have 2 separate concepts here. And so sometimes when you find these, you actually need to take those schemas and actually separate those apart. The refactoring database book talks a lot about how you can do those things piecemeal. So here, rather than having a very generic concept, I now need to be much more specific and explicit in what I'm doing here by pulling these 2 concepts apart. The key thing I want to try to get across here is that this will be a journey of discovery. It can be a bit concerning because there is no necessarily a grand plan other than the understanding that we want to model our services around these bounded contexts. What you're trying to do is high level and you start chipping away. The key thing to understand here is actually the cost of change. The cost of change around a whiteboard is very low. If you have a line in the wrong place, I rub it out, I draw a new line. It's kind of straightforward. If I'm working within, say, a code base of, say, within a process boundary, and I want to move some code between packages, it's a Shift F6 in IntelliJ. It's not an operation that should cause any errors. It's a very quick and easy thing to do, and if I make a mistake, I can roll it back quite quickly. Changing how services talk together is much more tricky, because if I get it wrong, the cost of that is much worse. Sometimes those services will be split between separate teams, for example. If I need to make a change, I might have to orchestrate deployments of 2 components. And changing the database is also likewise expensive. And this is all basically an argument for a little bit of upfront thinking. Not a lot, just a little bit. I think getting around a whiteboard and actually thinking about how these bounded contexts interact and what will they look like as services is a very sensible exercise. How many of you, when you were at university, did object-oriented theory and talked about class, responsibility, collaborator things? There's a few, right? And I suspect, like all of you, well, myself anyway, I did that at uni. and thought that was a really interesting exercise, and then promptly never used it ever again. And I think it's a huge amount of overkill for objects. I actually think, though, it's very sensible for services. Just get around a whiteboard. What's the responsibility of this service? How does it talk over here? Let's run a use case. Oh, this service is talking to this service like 5 times during this use case. Maybe that's a sign they're too closely coupled and should be one thing. Oh, this thing's got circular dependencies. We should tease those apart. These are very simple, easy conversations you can have around a whiteboard. And actually, some of the exercises around CRC cards work quite well there. So then the next question, of course, is, well, if I'm breaking these things apart, and I know that banner contexts nest within each other, I have the music shop, I have the warehouse, do I start splitting out within the warehouse, the concepts inside the warehouse? Do I go, how small is too small now for a service? There's good things about being small. A piece of code which is small is fairly easy to understand. So how small do I go before it causes me problems somewhere else? And this really is where a lot of the interest around microservices has come about. And the movement towards more fine-grained architectures has come about in large part because we've had a whole lot of enabling technologies that have reduced the cost of having more types of services lying around. We've got cloud, infrastructure, automation. And we've also understanding about architectural patterns in distributed systems is much more mature. And so we now have the ability to go much more fine-grained than ever before. But how fine-grained should I go? And what are the benefits of doing that? So I'm going to talk about that by talking about UNIX. So I'm a big UNIX fan. My first proper professional platform was looking after about 6 different UNIX variants. It's a lot of fun. Although C macros are evil. I should know I wrote a lot. And really, to understand why UNIX has been so successful and why Linux off the back of that has been so successful is because there is actually an ethos behind it that drove the successful deployment of so many different variants of this system with these same underlying principles. And I'm a great believer, like many of my colleagues, when designing a system, that having principles that help guide your way are very important. And here's Doug. Douglas McCroy did a lot of work at Bell in the early days of Unix, talking about what the Unix philosophy is. This is the Unix philosophy. Write programs that do one thing and do it well. Write programs to work together. Write programs to handle text streams because that is a universal interface. Sounds like a smart guy. This is back in this, I think this was 67. Just to ram home this point a bit more, there's a book called The Art of Unix Programming that I'm sure is a rip snorter, but I haven't read it. What I have done is found out about it on Wikipedia and copied bits of Wikipedia into my slides. There are basically in this book, I think it's about 17 rules of Unix that Eric Raymond talks about. And I think he's very serious when he talks about rules. And I've picked out a few rules that give you, well, that I quite like as for general rules for all systems. Here's the rule of modularity. Developers should build a program out of simple parts connected by well-defined interfaces. So problems are local, and parts of the program can be replaced in future versions to support new features. This rule aims to save time on debugging complex code that's complex, long, and unreadable. Okay, that's good. Good. The rule of simplicity. Developers should design for simplicity by looking for ways to break up program systems into small, straightforward, cooperating pieces. He kind of likes the small thing here, doesn't he? This rule aims to discourage developers' affection for writing intricate and beautiful complexities that are in reality bug-prone programs. I feel quite offended about this because I've been doing that for quite a long time. I like my big complex systems. And Neil talked earlier before lunch about this challenge that we often don't have constraints placed upon us, and therefore we allow our systems to become big and complex. This is my favorite one, the rule of parsimony. It's a word I don't use enough, parsimony. Developers should avoid writing big programs. Again, he's really driving the point home to the point of being boring now. This rule aims to prevent over-investment of development time in failed or suboptimal approaches caused by the owners of the program's reluctance to throw away visibly large pieces of work. Smaller programs are not only easier to optimize and maintain, they are easier to delete when deprecated. This is really, really important stuff. I think it's okay if the board of your company knows about the name of a system as a whole. If the board of your company knows the name of a service in that system, it's already too big for you to kill easily. This is the problem. They're big, they're visible. Lots of risks associated with it. If I need to change that, 'cause it's a pain in the arse, there's too much attention on me, I can't do it. These are the big, complex legacy systems we live with. If my service is nice and small, I can rewrite it, who cares? Dan North almost calls this designing for rewrite rather than reuse. Making things small enough that you can rewrite them in a new language, in a different way, just to make it easier to understand, more performant, or whatever it is. But we need to think about what UNIX thinks of as a program. A lot of you here probably have used Linux, and if you've got Macs, you've maybe used the command line. This is what a UNIX program looks like, ls. That lists a directory structure. I pass in text with command line arguments. If I want to connect it to another program, I have a uniform text interface. It's called pipe. So this will take ls and send the output of that to another program called grep that's going to look for the word Sam. This is small stuff. Now, I've been using ls for about 15 years. I know I've used completely different versions of ls, and even on the platforms I've been using for a long period of time, ls has been completely rewritten. The features I always used to use still work, and new features have been added, but that code has been rewritten fundamentally multiple different times. So think about our services then. We like to go small, but how small should I go? This is my colleague James Lewis, who's going to be doing the microservices tutorial with me on Thursday. James used to say, when he was asked how small should a service be, he said no bigger than my head. Now, the first time I gave this talk, I was in Poland in a multiplex cinema, and James's head was 4 times bigger than it is here, which was an awkward conversation to have. Initially, it was about saying, well, if I can fit all the code for service in one screen, and my head's about the same size as the screen, it was kind of that, but then we were saying, what about font size? And what James really means is that the service should be no more complex than I can understand. I should be able to look at and understand what that service is doing at that level of that service. It should conceptually fit inside my head, inside my brain. I've heard other people that say, there's certainly organizations that practice a lot of fine-grained architectures. They have like rules of thumb, like 200 lines of code is about right. 200 lines of code doesn't seem like a lot. Let's think about our shop. Let's think about our web shop. Let's think about the basket service. What am I going to do with a basket service? I'm going to add to basket. I'm going to remove from basket. I'm going to look at the basket. Even if this was backed into a database for persistence between sessions, I would actually be a bit embarrassed if I couldn't write that service in less than 200 lines of code, even in Java. Login. There's login, log out, am I logged in? That's 3 things I'm doing. Again, 200 lines of code seems reasonable. Registration, register. OK, next, recommendation. What's in my basket? What should I recommend? I'm being slightly glib, but when you actually take these contexts and break them apart, you suddenly start understanding your system doesn't seem that complex after all. And this actually allows you to focus on the essential complexity rather than the accidental complexity. That gets pushed to your interaction points. It's very hard to understand how these would be more than a couple hundred lines of code. And if I want to blow one away and replace it with something else, well, I can. Closure's better, so why wouldn't I? That can lead to these sort of big systems that are very, very fine-grained and have lots of interactions with each other. Typically, at this point, if I'm allowing questions, which I'm not because I'm worried about being behind time, you can ask questions later. Via the app, press the green button, is one of things like performance. One of the first things I did there was I actually took a service, I broke up the banded context within the same service, had different resource pools talking to the same database. That's obviously going to be slower, isn't it? What are you talking about, Sam? This is nuts. I've now got to make multiple service calls to assemble my application. That's going to be slow. And then we have a big fight about things. So at this point, I would just say a few things. Firstly, performance is not the most important thing. I don't care what application you're building. Performance is not the most important thing to you. What is features? You need some features. Otherwise, a very fast app that does nothing is useless. So there's always trade-offs. Performance is often vying against other things that are important to you. It's vying against the speed of delivery. It's vying against data durability, service availability, consistency of information. There's a whole lot of trade-offs you have. What does good look like for your system? What is performant for your system? Now tell me how fast your system currently is, and then we'll talk about how fast it's going to be when we make the change. So as always with these things, test. Quite often when you break these systems apart, you discover other opportunities to make your system faster. You actually start to break away some of the paths, and some features actually become faster because they're no longer shackled with the compute paths or the I/O intensity of another type of operation. So often people say, then how small should I go? Well, you want to go small. The constraint actually is not the lines of code. You get more benefit the smaller your service is because it's easier to comprehend the code. But too many services and too many types of discrete services can be problematic. And the other constraint that comes into here is your operational and architectural maturity. So what do you think of by your operational maturity? In the old world, we had one big service. And we might have multiple instances of that, maybe I'm load balancing them, and they sat on a big box. And this is a very easy model to understand, to comprehend. In the new world, we go to smaller services, and the first thing that a lot of people do is say, right, I'm now going to have lots of things on a box. Keep my boxes. This becomes problematic. Firstly, you've got some poor ops guy sitting there who has to go and deploy these things. And if people have picked different technology stacks, that's quite painful. Most shops I know that do very fine-grained architectures standardize on 1 or 2 technology platforms. So there might be a JVM and a Node.js shop. That's partly because you want commonality, you want probably some deployment mechanism needs to be pretty similar. But secondly, you get problems. In the old world, if I got an alert on a box and I only had one service on that box, I knew that, well, either that service is impacted by that alert or it caused that alert. The reasoning activities you go through when dealing with that condition were much simpler. Now when I have multiple services on that box, which ones caused the problem? What's the impact of that problem happening now? So this becomes a bit more challenging. So if you can, when you're moving to finer-grained services, still try and keep that one-to-one mapping between the service and the host it is running on. So rather than having big boxes with lots of small services, try and have smaller boxes with smaller services. This actually greatly simplifies the operational overhead in terms of understanding how a system is working. It also makes your life simpler in terms of provisioning. If you've got an example, an environment where you can provision these hosts on demand, maybe you're using anything from LXC all the way up to, say, VMs or Amazon or Azure for bringing up your compute, you can then bring up boxes, actually bring up services, and destroy them at the same time. This allows you to actually have to still keep the lives of your operational team a bit better. It's another problem to think about. If I had one big box, it's kind of typically has a binary state in terms of being happy. It's either up or it's down. It's kind of straightforward. It's on or it's off. What about when I've got a big system like this? It's all intricate. Now, what if this guy in the middle is down? Is my system up or is my system down? Don't know. It's a bit more fuzzy. It becomes a bit more confusing to understand. You have to get better, for example, at knowing that the guy up here in the top might have a problem because something downstream has a problem. You have to get very smart, for all of your endpoints need to map and understand the health of their downstream resources. You need to get good at monitoring response times of all of these individual components to understand where the bottlenecks might be. These are not problems you had in the past. With the one big box, if something was slow, it's the one big box. There's nothing else in the world. Now, in this world, if something's slow, what is it that's causing the problem? And so from an operational point of view, the amount of pain you're going to suffer is not down to how big or small a service is. It's going to be about the number of them, the number of those things you're managing. So you need to understand how mature your organization is in terms of handling not only the implications of, say, downstream outage and the architectural patterns required to ensure distributed systems themselves can be stable. And there I start with Mike Nygaard's Release It book. But also your operational maturity. How easy is it for you to provision hosts for your services? How easy is it to deploy services? Understand what's happening to them in production. And depending on where you are, maybe in the old school, I've got to rack a box up for everything, or maybe I'm in the new school, I can provision everything automatically on the cloud world. It's going to tell you where your appetite is for how small and how many of these things you can afford to have. And probably as a rule of thumb, I would start coarse-grained and get finer-grained, because you will learn things at one at a time. People say, how many services is a good number? I say, how many have you got now? And they say 5. I say 6. Go to 6 and then see what happens. And then go to 7, and then go to 8. And as you go, you will learn things and discover things. Do not go from 1 to 20. If you do, don't blame me, because your life will become a living hell. Because what will happen is you'll discover all the stuff you didn't know about downstream cascading failures and the pain of the operations team, and then the cloud hates you. Ultimately, this is all about a lot of trade-offs. But the key thing here is to start, as you mean to go on, is to slowly chip away and emerge and pull out these designs. Which banner context in particular you want to spin off and take out of your main service is going to depend on a lot of factors I talked about at the beginning. Maybe this area of code is actually, we need to scale up this feature set. Maybe it's that we've got a lot of changes that are happening in this one area of the code, and if you make it a separate service, that we can actually release those changes without affecting the overall system. It may be geography. Maybe all those sorts of things. But at least when you start getting those tensions now, you can think, OK, so what I need to do, where are the seams in my system? There's a lot of ideas that sort of are not really around distributed systems that have sort of helped interpret this thinking. You've got things like object-oriented systems and CRC cards. You've got things from the UNIX Unix operating system. When I also think about, I'd finished this presentation the first time, and I suddenly realized this reminds me so much of all the stuff that Mike Feathers talks about in his book, Working with Legacy Code. You take a big thing, you look for seams. And all I'm suggesting here is that those seams should follow the business domain or the domain in which you're operating. Because by nature, they tend to have, like, you might be in a fairly chaotic organization like I actually work in, but typically in most organizations, you have these explicit boundaries, explicit responsibilities, those interaction points, and they're great ways to actually model services on. So in summary, understand your bounded contexts. Where are they? How do they exist? This is actually a great opportunity for you as technologists to reach out to those people in your business domain. What are the things that we care about? Oh, so is that how those guys talk together? Well, why aren't we doing that in the code? Understand where the cost of change is. You probably don't need to have a big conversation about where you're going to move code to initially. When you start getting into wanting to make database changes or changes with how services talk to each other, do a little bit more upfront thinking at that point. Please, the most important tool you can have as a delivery team is a whiteboard and some pens and a board rubber. I do get surprised by the organizations I've been in where it's easier to get a new machine racked up than it is to find some board rubbers and things like that. It's insane. This is very much an incremental journey. You can chip away at this gradually over time. So actually, it's a very good way of getting confidence your system can be a bit more supple and a bit more adaptive. Find these seams, chip away, gradually pull things apart. The key thing for me is this has been fantastic in allowing organizations to experiment more. When you have a big service, all of my features are in there, and therefore all my risk is in there. And if I want to try a new language, try a new framework, the risk of that's huge. If I can break that apart and target changes to a small component over here that I'll try an idea out, does it work? If it doesn't work, it's actually fairly low risk. It's a bit of code. We don't change that often. It's not the end of the world if we get a couple of issues here. It actually allows you to be a bit braver. So not only in terms of addressing things like technical debt and being more adaptive in your thinking, but also in terms of bringing new technology and techniques into your organization. And so, and the last point is that while size is often important, and in general, smaller is often better, you have to go slowly to understand what your own level of maturity is around the architectural patterns and around your operational maturity. I think with that, I'm done. So I just want to say thank you very much. So hopefully some of you have asked questions on the special app. Oh, we've got questions. OK, thank you. OK, so a recommendation engine is not 200 lines of code, perhaps a network request to a cache response somewhere, but not actual algorithms for determining user recommendations. So what are you causing service based on that example? I think you could argue about this. I mean, simple genre matching would be perfectly acceptable, I think, as a recommendation system for many people. So I would say that is an example of a service. I was being slightly glib with the 200 lines of code. I think within an organized, I mean, the key thing for me is when you get into this microservice world, is it starts to allow you to concentrate on the sort of the real complexity rather than the incidental complexity. I could imagine a recommendation service that is just something as simple as saying, the CDs in my basket are mostly in the rock genre. I'm going to take the top 10 rock genre records and put those out as recommendations. It may not be very sophisticated, but it would be a start. That's a very obvious bounded context. I might then get a lot more sophisticated. I might start looking at the country you live in, the area you live in, the interests you and your friends have, and get more sophisticated. The key thing is, from the outside world point of view, no one notices. Just semantically, the responses get better. I hope that's answered the question. If not, feel free to glass me outside. Another question. When moving from big to smaller composed services, some things become simpler, but it introduces complexity between the services. Where is the root cause of a problem? Do you need to protect against that? There is more opportunity for failure. Any thoughts on that? Absolutely. Hopefully, I started touching on that at the end. You have to get very smart about the protocols you use to talk to each other. That's where upfront design is very important. A colleague of mine, Eric Dernenberg, uses an analogy where he talks about the concept of town planning versus architecture. With town planning, it's like SimCity. Right? You have my light industrial area here, I have my commercial area here. I don't really care what buildings appear in that space. I care a lot about the roads between them. You actually spend a lot of your time as an architect not worrying about what a team does inside the box and caring a lot more about what goes on between the boxes. The key thing is you start getting a separation of responsibility. The people inside the service just care about what their service is doing. The architect's thinking about the more complex things. So yeah, you need to monitor response times of every service. You need to look at downstream reporting of your dependencies. You're going to need to be doing trending, decent log aggregation stuff. It says a lot when you list out all the things that people who do fine-grained architectures do. It's a daunting list. It's a scary list, which is why start small, and you'll see when you need to introduce those concepts. I think we've got time for one more.
This is one.
Okay. Okay, so microservices make clear sense for back-end system, but how do you recommend exposing the service? Oh, good question. The services to front-end clients such as web, desktop, and mobile. One approach is to let the clients interact with individual services via discovery process. Another is a thin service-level facade, giving clients a single representation of the resources. Each has pros and cons. I'd appreciate your perspective. I think in the old days, where we only ever built websites, you'd have like a big UI web shop, and that would be all your stuff there. And you'd talk to all the back-end services behind the scenes. I think increasingly that doesn't hold water anymore. I think the key thing we can say is it's not the web and mobile, it's just we now have a lot of clients and we don't know who they are or where they're going to be. I actually tend to, in general, have the clients talk directly to the services as opposed to trying to create thin veneer services. What we're trying to do is really think about this idea of hexagonal architecture. We want to avoid this layered problem. A lot of the time when we have clients talking through a thin service layer where we're trying to push shared code into the server, we actually end up doing things like creating aggregation services and all that sort of stuff. And over time, that can be really hard to deal with. And you end up actually, you know, I've got a load of now stuff here specific about a domain concept that's actually really actually down here. I think common services for clients that make sense are things like handshaking for API keys, looking for accidental denial of service attacks, logging. You might have auth barriers if you're dealing with security to make sure people have got the rights. So in general, I favor clients going to the services and with the intermediate services being fairly agnostic and certainly have no understanding of the domain. There are times where you need to go a bit in the middle, but in general, stay over here, wherever this here is. I hope I've answered that question. How are we doing for time? We've got time for... Good. Any other questions? No? Okay. Well, thanks for your time.